Hello, welcome to the course Mathematical Foundations of Computer Science. We are going to study our unit 4 number theory. So let's understand why we have to study this course number theory. So in this unit we are going to study about basic important theorems like prime number theorem, Euclidean algorithm and solving linear Diophantine equation, Chinese remainder theorem and so on. So there are so many theorems like Fermat, Euler's theorem, right? There are so many important techniques in this course as part of our number theory. But why do we have to study number theory? Okay, so number theory is actually a branch of mathematics that explores the properties of numbers and the relationship between the numbers, right? It's a special branch of mathematics which purely deals with the numbers and their relationships. Okay, so why is this, where is this number theory used? It is mainly used in cryptography. Okay, what is cryptography? Again, cryptography is branch of mathematics, like another branch of mathematics, or it's a part of computer science. It's a course of computer science where we try to secure the message when two entities, two bodies are messaging or exchanging information from a sender to a receiver, right? A message is being transmitted from a sender to a receiver, right? The message should be, it should be private, it should be made as private. In your WhatsApp, if you see, it sometimes says that your chatting, all your chats are private or they are privacy, all they are private and they are secured, right? Because whatever message you are sending, whatever the user is receiving, it is being converted into some other format and sent to the user or the receiver, right? So in cryptography we propose lot of algorithms, lot of techniques we propose in this in cryptography. So those algorithms actually help us to secure the messages. Suppose I want to send hello from A, hello is not sent as it is twisted in some ways. Either each character, the next letter plus one is added as the key always and sent. If I want to send ABC, I will be sending BCD. I am not sending the actual message. I will do some twisting there, either adding +1 or adding +2 or so on, right? So whatever message is there at A, you are sending it to B, but not sending it directly. You are making some transformations in that message. For cryptography is that particular course which teaches us different techniques to transform the message into different way. In technical terms, we call it as encryption and decryption. Encryption and decryption. What is this encryption, decryption? Encryption means you whatever message you have, you convert into different format and send it to B. Decryption means from that new message, you are getting back your original message. Okay, so in this course of cryptography, it has lot of algorithms, a lot of techniques. In all those techniques, we will be using some mathematical concepts. Those mathematics we are going to study in this unit, number theory. Okay, so that's what number theory is, a specialized branch of mathematics that explores the properties of numbers and the relationship. On the other hand, cryptography is a division of applied mathematics concerned with the developing schemes and formulas to enhance privacy of communications. See, when you are communicating, when you are writing a message in WhatsApp, it is secured. It means it is encrypted and sent to the receiver, and receiver is receiving it. After receiving, it is decrypting automatically. Your message is secure. So we are actually doing some transformations using number theory. So we are going to study about the applications of number theory, right? We will study so many mathematical algorithms which will help us in understanding those cryptographical algorithms in computer science, right? So as part of that, we will start our learning our concepts. The first one is prime number theorem. Okay, the first important principle here is prime number theorem. If pi of x is a function which gives the count of prime numbers less than x. Okay, if pi of x is a it's a prime counting function. Pi of x is a prime counting function, assume, right? It means what is this count of what does this pi of x means? If I write here pi of 5, or let us, yes, if you take pi of 5, how many prime numbers are there less than 5? 1 to 5, how many prime numbers are there? If you see pi of 5, it is just 1. Okay, it is just 1 because no, 1 and 1 itself is the prime, right? 1 and 5 are the primes, less than or equal to. Okay, so pi of x is a function which gives the count of prime numbers less than or equal to x. If I say pi of x or pi of 5, answer will be 2. Pi of 5 value will be 2 because the prime numbers are this. If I say what are the what is value of pi of 10? If I ask you what is value of pi of 10, so number of primes less than 10. So number of primes here I will be getting under 10. I think we'll be getting here 2, 3, 5, and 7. These are the primes less than 10, right? Same way, if I ask you what is pi of 6, how many primes will I get here? Less than 6, will be getting 2, 3, 2, 3, and 5 are the primes which are less than 6. Okay, so here 5 will not come. In this case, pi of x, only 5 will come. For it is not 2. For pi of 5, it is 2, 3, that's it. 2 and 3, it is 2, right? 2, 3, and 5. These 3 are the prime numbers. So again 3, right? So what is prime number theorem? Pi of x is a prime counting function. It gives us the number of prime numbers less than or equal to x. Okay, and the theorem states that pi of x is equal to x by log x. This is the prime number theorem. Pi of x value is equal to x by log. It is approximately equal to x by log x. Okay, this is the prime number theorem. If you want, we can count with some examples. See, if you take x value as 100, if you take x value as 100, okay, how many primes we have? Generally, we have 25 primes here. Okay, if you take x equal to 1000, here we number of primes we have is around 168. So how are we getting this? You substitute here. So for 100, it is 100 by log 100. If you calculate log 100 value and divide by c, you will get somewhere around 25. You will get somewhere around 25. Okay, so prime number theorem helps us in finding out number of prime numbers. Approximately how many prime numbers are there less than x, less than or equal to x, which are primes. So if the question can appear like this, find out number of prime numbers, find out number, what could be the number of prime numbers in the range 1 to 1000. How many prime numbers are there between 1 to 1000? It means it is x by log x. So you can calculate this 1000 by log 1000 value you calculate, you will get the answer, but actual answer is 168. You will get a similar nearby answer, right? So prime number theorem helps us in identifying the number of prime numbers less than or equal to the given number x. That's why the theorem statement is pi of x is approximately equal to x by log x. This is the prime number theorem. Okay, right. Next, the next concept is congruence relationship. What is this congruence relationship? Congruence relationships is an equation like this: A equal to B mod M. Okay, we say if you are able to express a number, like if I write here 15 is equal to 3 mod 12. If I say it like this, see this example. What is the meaning of this statement? If you divide 15 by 12, the remainder is 3. The remainder is 3. Okay, these kind of, no, it is one way of writing 15 divided by 12 getting 3. So we represent it like this. We use here congruence relationship is identified using 3 equal to symbols. It is identified using 3 symbols like this. Don't write 2, we have to write 3. Congruence. Why are we writing that? We will see that in due course, right? So any equation which is represented in this form, A is equal to B mod M, are called congruent relationships. Okay, the one example is like this: 15 equal to 3 mod 12, right? These are congruent. Why we call it as congruence relationship? Why are we not saying equal? Why can't we say it is equal? Why are we saying it is congruent relationships? For example, if you see, just the same. So one example I'll take. Yeah, 33 3 mod 10. See here. Suppose if I have 33 3 mod 10. See this congruent relationship. Okay, when we say that any an expression is called congruent if a number can be expressed as B mod M format. If you are able to express in this format, then we say that is a congruent relationship. Why it is called congruence but not equal to? See, 33 is equal to, again this is in the format A equal to B mod M, right? This is true. 33 divided by 10, I get remainder 3. If I put here 43, this is also true, right? 3 mod 10. Even if I put 53 here, this is also true. 3 mod 10. If you see, for fixed values of B and M, for fixed values of B and M, right? A value is changing. We have A value, no, it is changing. It means for fixed values for B and M, there are so many A's. This condition is true. This condition also true. For changing A values and fixed B and M values, you have so many such equations. Okay, you are able to represent an equation, all these equations in the form A equal to B mod M. So B and M are fixed, but there are so many values for A, for which the condition holds true. For so many values of A, this condition A equal to B mod M holds true. That's why we call this equation as congruence relationship. And we have to here study some properties. Okay, in modulus operator, we will study properties of modulus operator. Now, if we are why we have to study about modulus, because we are saying mod M, right? We are saying this is our congruence relationship. Then there are some properties here. Suppose you want to find out A plus B mod M value. If you want to find out A plus B mod M value, okay, the first property here is the value is equal to A mod M plus B mod M whole total mod M. This is the expansion of this. A plus B mod M is written as A mod M plus B mod M into mod M, right? So this is the expansion of the A plus B mod N. Similarly, the most commonly used second property is A into B mod N. Okay, it can be written as A mod N into B mod N whole mod N. Okay, so these are the very important properties in modulus. We will be using this. We will be talking about congruence relationship. We will be talking about this properties of modulus in the theorems or algorithms which we are going to study in the this course, in this unit. Okay, so this way, if you want to find out, for example, if you want to find out 3 plus 4 mod 2, for example, its meaning is 3 mod 2 plus 4 mod 2 whole mod 2 will be the answer. Okay, so what is 3 mod 2 value? 3 mod 2 value is 1. 3 divided by 2, remainder is 1. You know, modulus operator gives us the remainder. It gives us the remainder. Right. 4 mod 2, it is 0. Whole mod 2. So we get here 1 mod 2. What is 1 mod 2 value? Whenever the A part, it is like A mod B, right? A mod B. If A is small and B is large, you write the A as the answer. So 1 is the answer here. Okay, so this way it is expanded. Maybe for the small number it is looking easy, but when we have big numbers, when you expand it and see, you need to apply these principles there, right? So with this, if you summarize what we have studied, we have seen about prime number theorem. It says that the number of prime numbers less than or equal to x is approximately equal to x by log x value, right? And congruence relationship, if you can express a number A as A equal to B mod M in this format, then we say they are in congruence relationship. A and M are in congruent relationships if you can express it like this, right? And we have seen two properties. First one, if it is A plus B whole mod m, or let anything, you can take odd mod n, then it is A mod n plus B mod n whole mod n, right? The second one was A into B mod n. So it is A mod n plus into B mod n whole bracket of mod n. So we'll be using these principles in the coming sessions. Thank you.